Assalamualaikum warahmatullahi taala wabarakatuh. Okay. Today we will continue from our previous lesson about conditional entropy. So let's recall. Any questions before we start? No, then. Okay. Okay, let's start. Okay, so we have this measure space with X, sigma algebra and mu. And we have psi that is given by this element. Okay, so we define entropy. H of entropy, or we call it as the entropy of the partition, is equal to the summation minus summation of I from 1 until n, measure of the element in the partition psi, multiply with the log of the measure of the element in the partition psi. And we also know about the conditional entropy. That is, if you want to find the entropy of the partition with respect to the element B, this means that we have our measure, or the entropy is given by this formula. The sum minus sum of mu. So here, since this is conditional entropy, so we have the subscript B in the measure, multiply again with the log of mu B of AI. And by substituting the definition of this measure, so we have measure of B of A is equals to measure of A intersect B over measure of B. So we substitute in our formula, then you have sum minus sum of mu of AI intersect B over, oh, where does it go? Okay, intersect AI over mu B log of mu of AI intersect B over mu B. So this is the second formula for conditional for the entropy. Okay, next. Okay, next we consider the third formula, which is the entropy of partition with respect to the second partition eta. So to get this partition, to get this entropy, we have to find the average. So the average of the entropy is given by this formula. So the sum of I from 1 until n, mu of B of I, multiply with the entropy of psi respect to Bi. And you need to find what is the entropy for this with respect to each element in the eta, or in the second partition. Okay, so for today we will continue with the new. So we want to find a new entropy, which is the entropy of the partition 3 or 2 or 3 finite partitions. Okay, so for this one, let us consider 3 partitions. So the first partition is psi, that is given by this A1, A2, A3 and so on until AN. So we consider finite. And the second partition is given by this element B1, B2, B3 until Bm. And the third partition we call it as zeta. So this is, we call it zeta, is equals to C1, C2, C3 until Ck. So this is psi, again, this is eta, and this is zeta. Let's try to find the elements in the joint partition. So I try to join the partition within psi, join with the eta. Okay, psi join with eta. So according to the definition in previous class last week, so psi join eta meaning the element, you have to consider all the possible intersections between the elements of both partitions. So we have AI intersect BJ, where here I runs from 1 until N, and J runs from 1 until M. Okay. Okay, now we can find the entropy. So the entropy of psi psi join with eta, given that zeta. How to find the entropy for psi join with eta, given that zeta? So for this one, this formula, to find this entropy, you have to remember this one. So you have the entropy of psi, or which means the entropy of the first, this one. See, I put this color. So this is 1, this is 2, and zeta is 3. Okay, so I would say H, or the entropy of the first one, which is psi, given that the third one, which is zeta. Okay, plus, so since this is join, right? So you have 2. So plus H, or the entropy for second one, so which is blue. And the second one is eta, given that psi join with zeta, or we could say psi 1 join with the third one, which is green. Okay, so that means for this case, for this formula of entropy, so you have psi, the first join with the second, given that the third one. So that means this is equal to the entropy of the first, given that the third, plus with the entropy of the second, given that the first join with the third one. So for the case of the given that, okay, we have zeta. So the third one should be on the right always. Must always be on the right. And the psi, first one, and then the second one. And then the second one should be, you have to remember this one, is psi join with the third one. Okay. So let's try, okay, for the particular case, okay, let's move on to next slide. Do you need time to copy? You can put in the chat. Yes?
Kenapa dia boleh pecah jadi macam tu?
This one formula dia. Dia tak ada, dia punya definition ni lah. Ni definition for joint. Untuk entropy for joint, joint is this, right? So join two partitions, so that means you have to find the all possible intersection between the elements in both partitions. So according to, this is the definition of the entropy for join partition with respect to the another partition. So for this case, for this entropy, this is equal to the entropy of the first given that the third plus the entropy of the second given that the the first join with the third. So ni definition dia. You tak boleh ubah dah.
Okay.
Okay. Okay, so now kita consider trivial case. Let us consider trivial case. For trivial case, you have if zeta equals to V, or we call it trivial set. Then, okay, so then you from this H or the partition of join with eta given that zeta is equals to H of psi given that zeta plus H of second one eta plus psi join with the third one. Okay, so then from this formula, so if zeta is trivial, and you know already kan, kalau trivial ni dia akan jadi the same. So they coincide with the original entropy. So that means our entropy of this joint is equals to, this one is equals to H of psi plus H of eta given that psi. Boleh nampak? So for this case, kalau zeta is trivial, so trivial set meaning that V is equals to X, or the whole set. Okay, so if this is trivial, that means we can cancel zeta, we can cancel this one, we can cancel this one. So there will be no zeta in the formula. We obtain this. Okay. Okay. Now we come back to our original formula here. Okay, I want to try to crop this. Can I? Copy. Okay, I have this formula. Okay, so let's try to find the entropy for this. Kita cuba dapatkan, kita cuba show the left hand side is equal to the right hand side. Okay, first I divide this equation or this formula into two parts. So this one I call it first, this one is second. Okay, first terms and second terms. And for the first term, let's try to find the first term. Okay, so I have entropy of psi given that of zeta is equals to, so according to the formula, so this is partition with respect to another partition. So you need to use the you need to use the formula number 3. So you have to find the average first. So you have k from 1 until L. Because I use k because the partition in zeta is in terms of C1, C2, C3 until Ck. Okay, so the measure, the sum of this is sum of the measure of Ck multiply with the entropy of the psi given that Ck. Clear this part?
Yes.
Okay. Okay, now what do you do? After that,
Expand.
I have to write, I write this in sum. So I have from k from 1 until L, mu of Ck. So this one you have to write in terms of entropy lah. So this one is the first formula, the second formula, which is the entropy of the partition with respect to element. So according to the definition of the entropy, you have the formula, the sum I from 1 until n of mu Ck of Ai. So because here Ai, because the element in the psi has A1, A2 until An. Multiply with the log Ck of Ai. Okay, boleh? Okay, now so I write here. So I can actually collect the from the properties of the summation, you can collect the sum. So I have minus from of k from 1 until L, and then you continue of and then the sum of I from 1 until n mu of. So here you have mu Ck, okay, multiply with, so this what is this formula here? This is mu of Ai intersect Ck, betul? Over mu Ck, correct. And multiply with log, again the same, log mu, here I use this one first. Okay, I don't simplify ni lagi. Okay, now. Okay, this becomes the summation from k from 1 to L to the summation of I from 1 to n mu, and this one you can cancel out, this one and this one. Okay, what's left is only mu Ai intersect Ck multiply with log mu Ck of Ai. Okay, clear this part for part 1?
Yeah.
Okay, now let's leave our answer like this, okay, for the moment. Okay, now we go to part 2. What is part 2? Entropy of psi given that psi join with the third partition. Okay, let's look at this. So this is from part 2. So I have entropy of the second one given that psi join with the third one. This is equal to, again you need to know, first you find what is this. Psi join with the eta. So what do you have? So you have AI intersect CK from, that means from I from 1 until N and K from 1 until L. Okay, so you need, that means you have to find the possible intersection between the elements of this partition. Then you can have, I can write this one equals to sum zeta, so sum of I and K. KKL. Okay, so here mu here, what about the mu?
Mu B I.
Mu B, mu BI. Okay, let's tulis satu-satu. Mu BI, BI pula. BJ. Mu BJ, right? Of C K. Oi, salah. Sekejap. Ni kita tengok entropi ni dalam bentuk apa? Partition dengan partition, right? So partition dengan partition, we have to find the third formula tu. Third formula, that means we have to find the average. So we have to find the average. So you can write here S, I, L until N, the same. So mu of
BJ.
mu of psi apa partition dia? A kan? Zeta partition dia C. Betul? So that means AI intersect CK. Boleh faham tak? Of the entropy, multiply with the entropy of zeta, AI intersect CK. Is it clear this part? Okay, let's try to read. Boleh So just to make sure that you understand. Okay, this is the second part. So for the second part, kalau kita ambil the partition, given that the partition, so you have to take the average. So the average mu BI. So BI is from the second partition here. So the same thing we apply for our joint partition. So our joint partition, this is for the second here lah, second part here. So you know psi join with the zeta is AI intersect CK, so you have to use that. So you take the average of mu AI intersect CK and you multiply with the entropy of the second partition given that the elements AI intersect CK. Is that okay, this part? Yeah. Okay, now, so we simplify. We can simplify the sum K from 1 until L, mu of AI intersect CK. Okay, now you can use the second formula. So the entropy of the partition with respect to the element. So you will have minus of this, I use J. Mu AI intersect CK of BJ. Log mu of AI intersect CK of BJ. Boleh? Okay, now. Now I can simplify or collect. I can collect all the sums. So 1, 2, 3. You got 3 sums over here. You collect them all and you write here. So I have 3 sums. I, and then K, and then J, mu of, okay, for this mu, what do you have? So actually you have this one. Mu of AI intersect CK intersect BJ. Multiply with the log of mu AI intersect CK of BJ. How do you get this? So you know, you can find this, right? You can find this conditional measure. What is this conditional measure? So mu of AI intersect CK intersect BJ, correct? Over mu BJ. Betul tak?
Bukan mu AI CK. Bukan bawah dia mu AI.
Sorry. Mu AI intersect CK. Betul. So you can cancel kan? Mu AI intersect CK intersect BJ over mu AI intersect CK. So this give you only BJ je lah. Okay. So when BJ and and then you intersect with BJ, so that means you have mu AI intersect CK intersect BJ. Is that okay? Boleh? Alright. Okay, now so you leave this. Again, I leave this answer. Nanti kita compare whether they are the same or not. So I put this in, let's say this is my number of equation or my symbol of equation. So if I use this asterisk, double asterisk, that means we refer to this equation lah. Okay, now we know already for part 1, for part 2 we got already. Okay, so now we can find from the left hand side. Okay, let's try to find the left hand side. I copy this again. Now I want to find the left hand side, which is this one. Okay, this one. You know part 1, part 2 already. So for the left hand side, I have entropy of psi joined with the second, which is eta, given that zeta. This is equal to, so again, this is the entropy of the partition with respect to partition. So you have to use the third formula, which is the taking the average. So you have sum of the third one, which is K, mu of CK multiply with the entropy of this one, psi join with eta given that CK. Okay, this part. Alright, so now you find this. This is equal to sum of K from 1 until L mu CK. And then you can find the entropy for the partition with respect to element, which is the sum. This one is AI dengan BJ. So I dengan from 1 until N and J from 1 until M. Mu of with respect to CK. So mu of CK AI intersect BJ multiply with the log of mu CK AI intersect BJ. So far okay? And you simplify. Kalau tak boleh, just interrupt me anytime, okay? So we simplify, we collect all the sums and we have K minus. We got minus over here. Belum ada minus tak? Did I put minus? Ni, I forgot to put minus. Ada minus dia. You got minus this one tak ada. This one ada. For part 1, yes ada. Okay. Sorry. Betul lah. Okay, so we kena be careful with the minus. So we got minus here. I have L, I have sum. Okay, we continue until N and then the third sum of J from 1 until M. Again, you can simplify. Mu AI. So this gives you mu of AI intersect BJ intersect CK over mu CK. Okay, and then you can cancel this mu CK and mu CK. And what do you have? Mu AI intersect BJ intersect CK. Okay, you still got 3. So you will have mu of AI intersect BJ intersect CK multiply with the log of so again you have mu CK dengan mu yang ini. Okay. For this part, okay. Kita buat slow-slow have to. Okay, let me cancel this. Nanti kita boleh faham. Kita tak payah simplify lagi benda ni. Okay, let me cancel this one. Okay, first we collect the sums and then we put in three, put them together, and then I have mu CK AI intersect BJ multiply with the log mu CK AI intersect BJ. Okay. So far this one is I don't do anything, I just collect the sum. So now So now height,
Pergi mana?
ya. Ana ada problem?
Mu CK tu pergi mana doktor?
Mana?
Yang sebelum summation tu, mu CK tu. Ni tak cancel lagi ke? Kan? Ni belum cancel lagi kan?
Oh tak cancel lagi. Sekejap Did I do something wrong here? So I want to cancel mu CK. Sekejap. Sekejap. I think I miss info here. Betul lah, kita kena simplify yang ni. So mu AI intersect BJ. Apa maksud dia ni? Intersect CK over mu CK. And then I can cancel mu CK and mu CK. So I have mu of AI intersect BJ intersect CK, correct? Multiply with log mu CK of AI intersect BJ. Is that okay? Okay. Alright. So kita biarkan yang ni dulu. So I want to show you this part. How can we write this conditional measure? Okay. So I start from here. Let me copy this. Lama tak best ni. Tak apalah, saya tulis balik lah. Okay, let me copy this. Let me tulis balik. Rewrite. So I have sum I K J 1 from N from to L to M. Okay, mu of AI intersect BJ intersect CK multiply with the log of mu or measure of CK, conditional measure of CK AI intersect BJ. Okay, so this is the green part. So for the green part, I can write mu CK AI intersect B, okay, is equals to we use the property of the conditional probability. So I have mu of A intersect A given that C multiply with measure of B given that A intersect C. Sebab apa yang ni? This one coming from mu of A intersect C over mu C. Betul tak? So instead of using that, I'm using this. I'm using this one, the conditional yang ada given that. Okay. So mu CK of A intersect B is equals to mu of AC, A given that C multiply with the mu of B given that A intersect C. Okay, this is how we can write this, the green part. So let us verify. First we verify mu. So mu of A intersect B intersect CK over mu C. Saya guna CK ke? C lah, C for understanding. So this one C, mu C is equals to, so here mu A intersect C over mu C, okay, multiply with mu of B intersect A intersect C over mu A intersect C. Okay, this one we use the definition of conditional measure. Okay, you can delete or you can cancel this mu A and C, mu A intersect C, and what's left is only mu B intersect A intersect C over mu C, which is equal to the left hand side. Okay, now let's come back to our equation here. Okay, I use this. So you know, okay, this sum. Now we want to simplify the sum. This log. We want to simplify this log. Okay, what do you have? I have a sum of the triple sum here. L, I1 until N, J from 1 until M of mu AI intersect BJ intersect CK multiply with this log. So I can write log mu CK AI intersect BJ in terms of log mu of A I given that CK multiply with mu of B. Sekejap, saya buat kecil sikit. Multiply with mu of BJ given that AI intersect CK. In the bracket. Log, again log log mu AI given that CK multiply with multiply with mu BJ given that AI intersect CK. So that means I just use this formula here. I rewrite my equation of conditional measure in terms of the first term here and then the second term. This. Okay, so change. Okay, so then what we have, you will get the triple sum. This give you again the triple sum K of I, L, I from 1 until N, J of 1 until M, mu of AI intersect BJ intersect CK multiply with log mu mu CK of AI Allah, sekejap. Blank pula. Okay. Mu AI conditional measure with CK plus log mu of AI intersect CK of BJ close bracket. Is that okay? Boleh tak? So for this part, I just use, so for conditional measure, we can rewrite this conditional measure in terms of this. Mu CK of AI. And then since this is a log, so we use log property, but multiplication become plus. So log mu CK AI plus log mu AI intersect CK BJ. Okay, and then then you can write the triple sum mu of AI intersect BJ intersect CK. You just expand. Okay, minus with sum of mu of I write here lah, minus sum of mu of AI intersect BJ intersect CK log mu AI intersect CK BJ. Okay, minus. So if you, let's see the terms here. So I write these terms as star, and the first term here as triangle. So in the previous calculation, let's see the this one. Let's see the 2 star here. So the 2 star is equals to minus of 3 sums with mu AI intersect CK intersect BJ multiply with the log mu AI intersect CK of BJ. Okay, so this is the green. So the green star give you this equation. Then after you calculate, you can get the red one. So this is for the second terms. Okay, second terms is equal to minus of 3 sums mu AI intersect BJ intersect CK log of mu AI intersect CK of BJ. So the same. So the same. So what does it mean? Kan kita daripada left hand side, right? So the left hand side here. So the left hand side here, we got already the second part, which is the apa tu red, the red star tadi. So the second part ni the red star meaning we have already got the answer. What about the first part, which is the triangle? So the triangle ni we need to show that it is equal to the entropy of formula tadi. Okay, now we try to find the so let's write here. So that means our star, we verified that our star is equal to the green star. Okay, now we go to the triangle expression and we show. For the triangle expression, this actually is minus sum. So kalau dalam exam jangan tulis sum je, tulis penuh sebab saya nak jimat masa. And okay, I have mu of AI intersect BJ intersect CK log mu CK AI. Okay, this is the triangle part. Okay, triangle. So let's verify it. We use this one. This is equals to minus of sum 1 until L, sum of I until M. Okay, so actually we can write this as multiply with the summation of J from 1 until M mu of AI intersect BJ intersect CK multiply with the log mu CK of AI. Why I bring this sum into the dalam bracket because we want to eliminate J. Bukan nak eliminate, maksudnya kita nak, yes, actually we want to eliminate because if you can see our, this part, the second, ni, we don't have, we will not have B in our last calculation. Yang ni yang the second. Ni. Ni triangle ni. We will not have B. Tak ada BJ pun dalam kita punya sum ni. That's why we want to eliminate B. Okay, so we go back. Sorry kalau pening bagi tahu. Okay. Okay, now we will simplify. So we have M sum of this. Sum, okay, I can write in terms of union. Now I can write in terms of union. Sum dengan union in terms of set. Okay, so sum in terms of value, union is in terms of set. So I can write this union from J of 1, okay. This is for the part. Warna apa lagi ni? Boleh pilih warna je, tak boleh pilih warna. Ini saya nak simplify yang in the bracket. Okay, kita nak eliminate B. So union of J from 1 until M, AI intersect BJ intersect CK is equals to. So I can bring the union inside. So I have AI and bring the AI outside because this union is depend on J. Okay, so I have union of J from 1 until M, BJ intersect. Jangan lupa intersect kat sini. AI intersect, okay. Intersect BJ, union of BJ intersect with CK. This is equals to AI intersect. So say the union of BJ is what? The whole X. Boleh? Okay, the union of BJ until from 1 until M is the whole X. So it means that it is equals to 1 lah. Union it equals to 1. So is equals to 1, so tak payah. So that means AI intersect CK sahaja. Okay. Okay, now you can use that. I have this information already. So I have a sum of K from 1 until L and sum of I from 1 until N. Mu of AI intersect CK. Because you already simplify log mu of CK intersect of AI. And this is actually equal to the triangle. That means our function, our formula here is verified. Okay. Here I write blue again. So just to make sure that maybe next time you want to see. This is equals to. Okay. So from let me repeat. Let's see. Okay, from this I want to verify, right? So the first part I verify the right hand side. So the right hand side have two expressions. So I divided into two, part 1 and part 2. So part 1 already you found this equals to the triangle. I call this expression as triangle. Now for part 2 I got this as 2 star. Okay, by using this we simplify. So the left hand side. Now we want to verify from the left hand side. we must use some of the property of the conditional measure. So this measure we change it into this form. Okay, and then we write it into our formula here. And I got in terms of log. And now I expand by multiplying with this three sum with the log, and I got two types of two expression, which is the triangle and also the red star. And in fact, this red star is equals to the second, the green triangle, the 2 star, because this is the second expression in the right hand side. Now we want to verify the first expression in the right hand side, which is the triangle. And what we do is also we use the property of the union of the set. Okay, and we want to eliminate J. So by finding the union of Bj, so actually we found this is equals to the whole X. So by intersection of the whole X with the AI and CK, we got only AI and CK. And because of that, we have simplified our a triangle expression which is equals to this one. And that means our expression here is equals to H of the psi given that partition, the zeta, that partition. Thus, you can write, so in conclusion, H of zeta, eta, given that zeta, this is psi, is equals to H of psi, given that eta, zeta, plus H or the entropy of second, given that psi joined with zeta, is verified. Since the left hand side is equals to the right hand side. So again, for particular case, where zeta is equals to the trivial, so I have H of psi joined with eta is equals to H of psi plus H of eta given that psi. Okay. Any questions?
Doktor, yang pasal problem tadi, saya blur je dekat dia entropi eta join with psi join with eta regarding susah ingat.
Ni. Proof yang mana? Proof yang mana nak
Okay, yang bawah tu doktor, yang dalam kurungan tu. Saya tak faham yang tu.
Ni, yang ni.
Dalam
kurungan square bracket ni.
Saya blur je.
Okey. Datang mana?
Your summation tu.
Triple summation ni datang mana? Okey. Kena tengok sini. Kan kita ada 3 formula yang saya recall mula-mula sekali kelas. Ingat tak? 3 formula, betul? So the first formula, entropy of the partition saja, betul? The second formula is entropy, conditional entropy of the psi ataupun partition with respect to element of the partition. Element of one of, maksudnya B ke, C ke, D ke, kan? Ni macam ni. Yep. And the third one is the entropy of the partition with respect to partition. Betul?
Betul.
Okay. So sekarang ni, yang dalam bracket ni, Okay, sekarang ni sebab kita tengok the third formula tu, kita use the third formula for this left hand side sebab join partition ni dia adalah partition dengan partition. Dia punya with respect to partition. Given that tu also partition. So kita kena guna the third formula. Maksudnya kita kena ambil average. Boleh? So the average darab dengan entropi yang ni lah. Boleh tak kat situ? Setakat ni. Boleh. And then ini mu CK, saya just tulis kat sini saja. Ini kenapa dia ada double sum? Sebab dia ada dua, AI dengan BJ. Macam mana dapat AI dengan BJ? Boleh faham kat sini? Macam mana dapat AI dengan BJ? Ni kan? Sebab join. Sebab psi adalah A1 until AN. Betul? Eta adalah B1 until BJ. BM, sorry. So kalau kita nak cari join, so that means kita kena cari AI intersect BJ. Kita kena cari the list of possible intersection between these two elements. Boleh faham kat sini? Setakat ni? Okay. Sekarang ni, so kita just use the formula of entropy yang ni. Ni kita guna formula entropy yang biasa. Sebab ini with respect to element CK kan. So kita guna yang the second formula. So ada dua sum sebab AI dengan BJ. Kan kita kena cari A1 intersect B1, A1 intersect B2, A1 intersect B3 and so on. Lepas tu kita cari A2 intersect B1, A2 intersect B2, N2 intersect B3 and so on. Sebab tu kita ada dua sum kat sini. So minus, kalau satu elemen AI saja kita ada satu sum. Tapi kalau ada dua AI dengan BJ, that means we have two sum. So this is conditional measure. Conditional measure, kita guna definition of the conditional measure. Darab dengan log mu CK AI BJ. Yang ni. Apa conditional measure? H of psi given that C, okay, is equals to minus sum mu of C AI darab dengan log mu C AI, betul? Kat sini, kita guna kat sini, dalam square bracket ni.
Bukan terbalik kan?
Terbalik?
Betul.
Boleh lagi?
Boleh.
Lepas tu, kan mu C conditional measure according to our formula is mu AI intersect BJ intersect CK, betul? Over CK. Lepas tu dah ada mu CK kat sini, kita boleh cancel. So what's left only this lah. Mu AI intersect BJ intersect CK. Boleh?
Boleh.
Tapi saya tak simplify lagi log mu CK AI intersect BJ sebab kita nak guna property of conditional measure yang dekat hijau ni. So saya biarkan dia dalam bentuk ni dulu. Okey. Saya dah faham tak?
Dah faham dah.
Dah.
Okay.
Okay. Any more questions? Okay, if not then I can kita consider example. Tapi you can do it and try to verify by yourself. Okay? Ni home task lah, home task. Okay, so I have this segment, a segment, and I have three partitions, psi, I have 0, 1 over 3, 1 over 3 to 2 over 3, and 2 over 3 until 1. Okay. Next, I have the second partition eta, 0, half, and then half until 1. And next one, I have the partition, tak ada partition, only those two partitions saja. Okay, so try to find the entropy of zeta join with psi. So how you write this? So you know from the formula, kalau yang ni h of psi join with eta given that zeta. Kalau for this case, that means dia trivial je lah. So that means you know, you go for the particular case here. Ni. So by using the formula in the particular case, so I have entropy of eta plus entropy of psi given that eta. Okay. Okay, now if I exchange the position, so h entropy of psi given that eta, this is equals to h of eta join with psi minus h of eta. Okay. Kalau in previous examples, you know our h eta is log 2. Sebab apa log 2? Sebab we know this is symmetric. This is symmetric. Kalau symmetric, dia ikut daripada number of elements in that partition. So ni ada 2 elemen dalam partition, that means dia log 2. Kalau 3 elemen, maksudnya dia log 3. Tapi ini adalah apply for the symmetric element. Okay. Tapi kenalah tunjuk macam mana dapat log 2 kalau dalam soalan lah. So kalau nak cari yang ni, that means you have to find the join partition lah. So that means eta join with psi, this is equals to you have to find AI, A1 intersect B1 intersect A1, B2 intersect A2, sorry, B1 intersect A2, and then B1 intersect A3, finish. And then you have B2 intersect A1, B2 intersect A2, and B2 intersect A3. Okay, and then you can find all the possible values lah. If you let this one as A1, A2, A3, and this one B1, B2. Okay, now you know the join, so you can find the another apa tu? What is the element, the value in the join partition? So you can find what is the value something. So entropy of this is equals to something. Okay, so let's say you got the answer. Entropy of the left hand side is equals to this one. So that means you have to verify that entropy of the right hand side also the same. So you know h of eta is log 2. So that means log 2 plus something lah. So kalau belah kiri dapat log 2 plus something, so belah kanan pun dapat log 2 plus something, that means your answer is verified. You have proof that the left hand side equals equal to the right hand side. Okay, you can try this on your own as home task and try to verify the formula. Okay. Alright, so that's all for today. Any questions before we end our class?
No.
No. Okay, so just do the exercise and home task so that you make familiar with the terms of the entropy and also the symbol. The symbol. So kalau dalam exam, the symbol used could be quite confusing. So maybe you should know which one is psi, which one is zeta, which one is eta. Tapi kalau tak tahu pun make sure that you know you can write this is as A ke, A or B or C, so that you know which one that you need to find. Kalau tak, confused. Okay. So if no questions, then that's all. Next week class, we still have another one, right? On Tuesday. Kita ada kelas lagi ke hari Selasa?
Rasanya macam
Ada kan? Ada ke tak ada? Cuti ke tak? Cuti ke masa tu? You start cuti bila? Cuti raya-raya 12 ke 11? 12 I think 12. So for the next week class, it's okay. If you don't have, we don't have class, but I will rakam lah. I will do a synchronized video and then upload in iTalim. So in case kalau ada kelas, you can still watch. Kalau tak ada kelas pun tak apa. It's just next in after kita habis kelas after raya nanti, at least you have the video and then we can continue. Okay. Alright, so that's all. Thank you class for your patience and also for your attention. So before we end, so I would like to say Selamat Hari Raya. Maaf zahir batin. And I hope that our deeds in Ramadan will be accepted, and we hope that we will again meet also next Ramadan, insyaAllah. Okay, with that, I end with Assalamualaikum warahmatullahi ta'ala wabarakatuh. Thank you class.
Thank you Doktor. Selamat Hari Raya.
Hari Raya.
Thank you, Doktor.
Okay.
Thank you, Doktor.
Welcome.